Question number 72 is similar to the last two questions in that we have to make sure again that we differentiate between what parts represent the ratios versus what parts represents the angles. So again, I've kind of color coded this. This arc cos represents an angle that, in fact, the arc cos is the angle theta. I'll maybe change that 2. That 2 is not part of it. The arc cos is the theta there. X is a ratio that gives us a cosine. So the ratio that gives us cosine is adjacent to hypotenuse, or adjacent x over the radius. So these are the parts here. And again, I'm going to define the arc cos of ratio x gives me the angle theta. Okay, so that's how I define this. So basically, I'm trying to find the sine, an expression for sine of 2 times theta. And I want this in terms of x or sine and cos parts. Okay. Well, this in fact is an identity. Sine of 2 theta can be rewritten as 2 sine theta cos theta. And I know that cos theta already has been defined here. The cosine of this angle is going to be the adjacent to the hypotenuse, so that really, this value is really just equal to 1. That's for x. So this piece here is equal to x over 1. I'm just going to write that as x. Sine theta, well, it's going to be this length here, so it's going to be 1 minus x squared using Pythagoras. So this sine theta part can be rewritten as 1 minus x squared. And I bring down the 2. Now I've actually got an equivalent expression to sine of 2 theta, which is really sine of 2 times arc cos x. And so the equivalent expression then would be 2 root 1 minus x squared times by x.